Good morning, student. In our previous video we have completed second chapter in physics, and today in this video we are going to start our third chapter, and the name of the chapter is energy. Here we will learn about work, energy, different forms of energy, transformation of energy, and conservation of energy. These are the topic which we will learn one by one. Let us start from the very first topic, that is work. Here in the book it is written, work has different meanings for different people. If we are talking about work, it has so many meanings for different people. When we study, suppose if we are doing some study, we can say that we are doing mental work, because while we are doing our studies, our brain is in work. That's why we say that we are doing some mental work. When a worker carries bricks and cement to higher floor of the building, he does physical work. If a worker or if any of the person is doing or carrying some brick or cement to a higher floor, that means he is doing some physical work against the force of gravity. But in science, these are the normal meaning of the work. But in science, work has a definite meaning. The technical meaning of work is not always the same as common meaning. The technical, according to science, work is something different, and according to normal meaning, work is normally whatever we are doing, we say that we are doing work. But in science, there is certain condition to work to be done. Let us see what are the condition. First we will define work. Work we can define as, if a force is applied on a body and the body covers some distance, then we can say that work is done. According to science, work says if a force is applied on a body, if we are applying any force on a body and that body covers some distance, it means that that body changes its position, then we can say that work is being done. Let us take some example. Suppose pushing car. If we are pushing a car and car covers some distance, if we have pushed car and car covers some distance, then we can say that we have done. If we are pushing a car, suppose force is being applied on a car, and after some time we can see that car has reached in this position. Earlier car was here, after applying the force car has covered this much distance, then we can say that work has been done. It means force is applied and body covers some distance. This is the technical meaning of the work. If a force is applied on a body and the body covers some distance, then we can say that work is done. In science, only this can be said as work, nothing else. There is a formula for work. Work is equal to force into displacement, or you can say that force into distance, or you can say that force into distance. If we write the symbol, then we can write W is equal to F into S, that is W is equal to Fs. F stands for force and S stands for distance or displacement, whatever we are talking about. Now let us see what book has written in the definition of work. If you lift an object above the ground, you do work. If we are lifting any object from the ground, we are doing work. If you pull some object, you have done some work. In these cases, you applied some force. As we have discussed, force should be applied. You applied some force which moved the object. Which moved the object? It means object covers some distance. In science, work is said to be done only if force moves an object. If a force moves the object, then we can say that work has been done. Now, work done depends upon two things. Work done depends upon, it depends upon two things. The first is force, that we can say that magnitude of force, how much force we are applying, magnitude of force, how much force we are applying. The second thing depends upon distance, how much distance is being covered by the body after applying the force. That's why the formula for calculating the work is W is equal to F into S, force into distance. Hope that the definition of work and the starting introduction concept of the work is quite clear to you all. Let us move to our next topic, that is unit of work. Next topic we will discuss unit of work. Unit of work. As we have studied just now that the formula for work is force into distance, then what we will do, we will form the unit from this formula only. We have studied that unit of force is Newton and unit of distance is meter. Then we can say that unit of work is Newton meter. We can say that unit of work is Newton meter, and which is also called as joule. 1 Newton meter is equal to 1 joule. We can say either Newton meter or we can say that joule. Joule is being named by name given on the name of a scientist. A scientist was there, his title was Joule. That's why the unit of the work is given as joule. And the same joule unit is for energy also. Now let us define 1 joule. What do we mean by 1 joule? How we can define 1 joule? When 1 Newton force is applied on a body, when 1 Newton force is applied on a body and that body covers a distance of 1 meter. When 1 Newton force is applied on the body, if we are applying a force of magnitude of 1 Newton and after applying the force the body covers a distance of 1 meter, then we can say that work done by that body is 1 joule, like this. W is equal to F into S is the formula. In place of F, what is the force? 1 Newton. In place of distance, what is the distance? 1 meter. When it both will be multiplied, 1 into 1, it will be 1 Newton meter, or we can say that 1 joule. This is the definition of 1 joule. When 1 Newton force is applied on a body and that body covers a distance of 1 meter, then we can say that work of 1 joule is being done. Hope that this one is also clear to you all. Let us move to our next topic. Some examples is given in the book. Let us discuss these examples, how to calculate the work by using this formula. Here we can see that one example, that is one numerical is given, a force of 5 Newton. It means the value of force is given 5 Newton when applied to a body displaces it 2.5 meter. It means distance is given, the value of S is given 2.5 meter. Find the amount of work done in this process. Question has given us amount of force applied. Question has given us amount of the magnitude of the distance, and question is asking to find the work. As we all know that the formula for work is W is equal to F into S. What we will do, we will put the value of F, that is 5 Newton, value of S, that is 2.5 meter. We will multiply it. 5 5 ja 25, carry 2, 5 2 ja 10 and 2 12. after one digit point is there, after one digit Newton meter. Either you write 12.5 Newton meter or you can write 12.5 joule. This will be your answer. So easy numerical was there. And let us see, after this we can move to the next topic. Now next topic is condition of no work or zero work. What are the condition which makes us no work, which we can say that no work is being done and or zero work? So let us see the condition, then we will see the examples also. Suppose, as we know that formula is W in F into S, W is equal to F into S. If any of these two quantity is 0, if any of these two quantity is 0, any of these two quantity is 0, if out of these two quantity any of these quantity is 0, then work done will be 0, because if any of the value is 0, when anything will be multiplied by 0, the result will be 0. Now let us see few example. Here in the first example you can see a boy is pushing the wall. Is it possible for this boy to push a wall? It's no. The wall will not cover a distance. Even the boy is applying so much force in pushing the wall, but the wall is not covering a single distance. That's why the distance will be here 0, and if it is multiplied by 0, then work done will be 0. Now next we can see one more example is given there. A passenger standing stationary at a railway platform. This is a passenger. It is standing by keeping a heavy bag on his shoulder, and this bag he is standing, still he is standing, he is not moving from his position and keeping a heavy bag in his shoulder. Here we can also see that even if he is not moving, that means distance is 0. That's why work done will be 0. As we have discussed, in any of these two quantity, any one of it is 0, then work done will be 0. Now today in this video up to here we are doing. Next we will start from energy.